Okay, let's take a look at this problem here. We have to solve 2 cosine theta plus 1, so it's a plus right here. Okay, plus 1 is equal to 0. And we have to do it both on this first interval and then also on this second interval. So I'm going to walk you through this one. It's going to be, we'll put a lot of depth into this problem. Okay, and then on the next couple, I'll go through them just a little bit more quickly. So what we're going to do is first I'm going to solve this thing algebraically. So I'm going to go ahead and solve for the missing piece. What I want to find is I really want to find theta. Okay, so that's what I want. I want to know what is theta equal to, like when you solve for x or y or whatever it happens to be. Okay, I want to solve for theta. However, to solve for theta, theta is stuck inside this function cosine. So what I'm going to do first is solve for cosine. So I'm going to move everything else to the other side and leave cosine by itself. So step number 1 would be to move this 1 over. So we have 2 cosine theta is equal to -1. And then we divide both sides by 2. So the cosine of the angle is equal to -1/2. Now what we do is we apply the arc cosine function to both sides. And you can use either arc cosine, or you can use arc cosine like that. It doesn't matter. So I'm going to use the second one here. So we use arc cosine. Now over here, it's not that these two necessarily cancel each other out. It's just that the output, the way that a function works with its inverse is the output, just this input is the output, okay? So this function does something to it and then this undoes it, so we end up with just theta. If you want to think about them like canceling each other out, that's fine now, but that's really not what's going on, okay? The process is not that this cancels this, okay? It's that this guy gets plugged into here, gets a number out, and then gets plugged into here and comes back out. And that's the definition of an inverse. So what we have is that the angle we're looking for is equal to the arc cosine, or inverse cosine, of -1/2. So what that means is the following. We need to first find all the solutions for this on this interval, -pi to 2pi. So here's -pi. Here's 2pi. Now by definition, this guy right here is only going to kick out one answer on our calculator or with the computer program. So what this says is find an angle whose cosine value, okay, we introduced this ourselves. So this one right here says, and I'll do it here in green, okay, it says between -pi, which is here, okay, and I'm going to go all the way around until I hit, now notice I'm going to overlap here until I hit 2pi. Started at -pi, went to 0, went to pi, went to 2pi. Okay, so that's what I end up getting. Now the question is, what angles on that interval, on that wrap, give me a cosine value of -1/2? Okay, well, the answer just to this right here, the answer to this is we need a cosine value that's -1/2. So it's going to look like this length right here has to be -1/2. So that's going to be at 2pi/3, right? Because pi/3 is here, 2pi/3. So the answer to this right here is that I get 2pi/3, but that's only one solution. Okay, so again, what I want you to get across here is that we introduced the arc cosine, so when we get an answer out, we're only going to get one guy out here, but we need to find all the guys on this interval. So where does 2pi/3 fall? And well, here's 0, and so 2pi/3 is somewhere there. Now let's look at the other angles that have a cosine value of -1/2 that fall on this. Well, first, over here, cosine is positive, so there's going to be no answers on this part or on this part. They're all going to be over here. So clearly there's another angle down here that has a cosine value of negative 1/2. So 2 pi over 3, 3 pi over 3, looks like it's going to be 4 pi over 3. Okay. But we could also go this direction, the negative. And so negative pi, okay, as I go this way, negative pi, I'm also going to hit this guy right here, which is going to be negative 2 pi over 3. You can just think about this thing as like laying it out flat. Okay, now what I'm going to do here for you is I'm going to graph this out. I want to show you what else we can see. So we can look at, I know you can't see this whole thing. Let me bring it down into the screen. Okay. So the equation was we wanted 2 cosine of theta, but use x here, okay, plus 1. And we want to know when is that equal to 0. And we wanted an interval, okay, we wanted an interval from negative pi to 2 pi. I'll do my, it doesn't really matter what I do for my steps here, but I'll do pi over 4. Okay, so what we want is where's the blue line and the red line cross? Well, there's one guy, and there's another guy. And so notice that negative 2 pi over 3, 2 pi over 3, and 4 pi over 3 are the answers. Again, negative 2 pi over 3, 2 pi over 3, and 4 pi over 3 are the answers. So we can check this. We can take a look at this guy and we can check it graphically as well. Now don't get used to just using this. You want to be able to do everything out by hand as well. Okay? So I guess I shouldn't have said 1. I guess I should have said part A over here. Okay, now let's look at part B. Part B asks over the entire interval from negative infinity to infinity, right? Well, how many answers are going to be in here? Well, we had only 3 over this interval, but if we keep going in both directions, we're going to have an infinite. There's an infinite amount of answers. How do we compute this? Well, what we're going to do is we're going to notice a pattern right here. So what was the pattern? Let me erase all this and clear this up a little bit. The pattern was, ugh, that's horrible. Let's try it again. Okay. Now the pattern is that once we got to here and we solved for this, okay, we got kind of 2 basic answers really from this. The 2 spots in the unit circle that had a cosine value of negative 1/2 were at 2 pi over 3 and 4 pi over 3. Now notice that if we keep repeating, if we keep rotating around, we'd end up back at those same spots, and any of those values would be answers to this initial problem. So what we have are 2 pi over 3 plus all of the times that we can wrap around to this. So plus 2 pi, but we want to do it a bunch of different times. So we're just going to put a variable in here, k. And we're going to say that k is an integer. What we mean by that is that k belongs to, or is an element of, negative 3, negative 2, negative 1, 0, 1, 2, 3. So that's 1. This right here, if I plug in any value for k that's in here, it'll be a solution. Like, watch. Let's say k was equal to 1. Then I would get, that would imply that I would get 2 pi over 3 plus 2 pi times 1, which is 2 pi over 3 plus 2 pi, which is 2 pi over 3 plus 6 pi over 3, or 8 pi over 3. Now, when I get to the end, I'll show you that 8 pi over 3 is also a solution. Okay, this is one part of the answer to this, but there's another part with the 4 pi over 3. So I'm going to do the exact same thing, but I'm going to put a 4 pi over 3 in there. Just like that. Okay, so now let's go ahead and let's take a look. Here, if I extended my range, let's say we went from negative 30 pi to 30 pi. What I want you to notice is all of these different spots right here, they're all solutions. Okay, now if I zoom in on them, notice here, here's my 8 pi over 3, and like I said, 8 pi over 3 was going to be a solution. And so what we've done, this first guy right here, okay, this first guy, if I go over here, is all of these. It's this guy, this guy, this guy. Notice I'm just adding 2 pi. So here, add 2 pi, add 2 pi. Okay, so add 2 pi, add 2 pi, add 2 pi. Or we can subtract 2 pi. So from here, we subtract 2 pi, subtract 2 pi, subtract 2 pi, so on and so forth. Okay, and then the other answers, the other dots in there, come from this guy right here. Okay, so over here on the right hand side in this ugly mess that I've now drawn, these two boxes are the answer to part B, whereas the answer to part A are just these 3 angles.